we're continuing on with our experimental probability, and when we talk about probability, oftentimes people talk about probabilities in like words or phrases. In other words, when we just talked about you winning the Powerball, if you were old enough to buy Powerball tickets, which you're not supposed to be, if you were old enough to buy a Powerball ticket, what in words, what would be the likelihood of you winning the Powerball? Trey?
Very unlikely.
Very unlikely. Yeah. It's such a small probability that it would be very unlikely, wouldn't it? Okay, how about would it be impossible?
No.
What makes it impossible?
When you don't buy tickets.
When you don't buy a ticket. Yeah. In other words, if you buy a ticket, do you have a chance?
Yes.
You have a chance, no matter how slim it is, no matter how small it is. So impossible means there's a zero probability. So look at our like kind of almost looks like a number line here. When it's an impossible probability, there's a 0% probability. When it's unlikely, or as we said, very unlikely, that would be really close to zero, wouldn't it? When it's unlikely, it's between what and what? It's between
0 and 50.
0 and 50. Doesn't include them though, does it?
No.
It's unlikely when it's between 0 and 50. So in other words, you know how the weatherman always gives the chance of rain? The chance of getting rain, instead of not getting rain, they always give it as the chance of getting rain as like 30% chance. If they give us a 30% chance of getting rain, what's the likelihood of it raining?
Unlikely.
It's unlikely to rain. It's more likely to do what?
Drizzle.
Not rain. What's the other choice? It's either raining or it's not, right? Whether it's a drizzle or a pour or whatever it is. Okay. So when the percentage is between 50 and 100, what do we say it is? What's the words we use? It's likely. So when they say it's a 30% chance of it raining, it's unlikely it's going to rain. It's more likely it's not going to rain. But yet they tell us it that way. Instead of saying there's a 70% chance of it not raining, they say there's a 30% chance of it raining. Okay, what's the word we use for when it's a 50% probability?
As likely as not.
As likely as not. In other words, it could happen. As likely as it could not happen. If you have a 50% chance of getting tickets to Garth Brooks yet, you have as good of a chance of getting one as you don't have a chance of getting one. Okay. And then when it's 100%, what's true?
Certain.
It's for certain. If I say I am going to pass you, there's a 100% probability I'm passing everybody in this class. You can all walk out of here certain that you're passing this class. Because I said I have all 100% chance you're going to pass this class. That means you get to go out there and say, I'm certain I'm going to pass this class. I haven't even taken the final yet, but apparently I'm going to pass this class. Okay, so we are going to talk about probabilities in words today. The other thing we're going to do is we're going to make predictions based on our experimental probabilities. First of all, we have to find the probability from an event happening, and then we're going to use that probability to predict what would happen using this probability. So in this one, we had inspectors who tested 500 cars for smog emissions. Where would they want to be? Where would they care about that? In Valley State, North Dakota?
No.
Probably not.
Los Angeles.
Los Angeles, they care about it, yeah. So they tested 500 cars. How many trials did they run? 500. They tested 500 cars, they ran 500 trials. 13 of them failed the test. What is the experimental probability that a car chosen at random will fail the test? So what was the event? What was the event in this one?
You're testing for smog.
Well, what was the event? It's what they're finding the experimental probability for. What's the event? Malcolm, what's the event? Trey?
Failures.
Failures. The event is the failing the smog emission test. That's the actual event. And in this one, it happened how many times? 13 times. So notice what they did. They found the probability. Would you take out your calculators, please? You're going to need them anyway, probably. So would you just divide 13 by 500? 13 times the event happened. Divided by the number of trials, 500. Does it come out to 0.026?
Yes.
Okay, and then when we change that to a percent, it's 2.6%. So we're actually going to, today when we do this, we're going to get both answers, okay? Then, now that they found out that it is a 2.6% chance, the question is it likely, unlikely, certain, impossible, as likely as not, that when you test a car, it will pass it'll fail the smog emissions test. Is it likely to fail? No. It's what?
Unlikely.
Unlikely. Why is it unlikely?
Because it's only 2%, so it's about zero.
Yeah, it's only 2.6% according to our experimental probability, so it's in that category between 0 and 50%, isn't it? Okay, now in part C, 125 cars are scheduled to take the smog emissions test. So here we are, they're going to test 125 cars. We're going to predict how many, before they even do it, we're going to predict how many of those cars are going to fail the test. Well, we have to take 2.6% of 125, our probability, times our number of trials this time, change it to a decimal, which is the 0.026 form, and they got 3.25. You see if you get that. If you take 0.026 times 125, 2.6% as a decimal, times 125, you get 3.25. What do you get? Well, I think something went wrong. It's 0.026 times 125. Multiply, yeah. 3.25. Well, we can't have a fourth of a car, right? So we would predict that about 3 cars would fail the test on those 125 trials. Okay. Okay, so let's do a couple of practice ones together here, just so you know how to show work for these on your homework. A machine assembled 600 boxes. What's that 600? Number of what? Trials. An inspector notices that 594 of the boxes have no defects. What's the event?
No defects.
No defects. What is the experimental probability that a box chosen at random will have no defects? Make sure you read the question. We want to find the experimental probability it will have no defects. So what are we going to have to put upstairs in our fraction? 594. What are we going to put downstairs?
600.
600. And then we're going to do what with that? Divide. Okay, go ahead and divide and get the decimal answer first. 0. What? 0.99. Okay, does it come up exactly to that or does it keep going? Exactly that? Okay, cool. And then we're going to say that is what percent?
99%.
99%. Okay, so that's a 99% probability that what?
That will not have
These
defects.
boxes don't have any defects. Okay, so what percent do then? 1%, right? 1% of them do. So is it impossible, unlikely, as not, likely, or certain to occur? Unlikely, because why? It's between 0 and 100. That's the unlikely phrase. That's 0 to 50. So I'm talking about the no defects. That's likely, isn't it? It's likely the boxes will not have defects. It's a 99% chance. It's likely that you grab a box from this group, it's not going to have any defects. So now the machine assembles another 800 boxes. Before it assembles it, let's predict how many boxes will have no defects. What are we going to have to do?
Well, 99%.
So we'll use the decimal name, right? So we'll use the decimal name, and we'll show this. You don't get to use your calculator unless you show me what's going into them. 0.99 is going to get multiplied times what?
800.
800, our new number of trials.
792.
How much?
I got 792.
792. Everybody agree with it? No. That was the experiment that was run, 594 over 600. We found the probability that boxes did not have defects from the experiment, now we're making a prediction for this machine assembling 800 more boxes. What do we predict? So now we're saying 792 out of those 800 should not have defects, right? Okay, what are we going to label this 792? What are they? Boxes. And those are undefective boxes, really, right? The ones that do not have defects. So out of that 800, how many would be defective?
Eight.
8. Is 8 1% of 800? Do you guys not know how to find that 1% easily? You take the number and you move the decimal point back 2 places. 1, 2. 8 is 1% of 800. So our two things should add up together. Either they're defective or they're not. So we got 8 of them that are defective, 792 that would not be. Add together, that's 800. 1% plus 99% is 100%. Okay, you go ahead and do this one on your own. Show me you know what you're doing. So, according to the experiment the owner ran, how many times did his vending machine, his or her, I don't know if I ever said it yet, is a he, how often did his vending machine dispense, what percent of the time did it dispense wrong change?
4%.
4% of the time. So, you know, they had these customers who kept saying to him, your machine always makes wrong change. What could this owner come back and say now?
That it only does it 4% of the time.
That what?
That it only does it 4% of the
Yeah,
time.
according to an experiment I ran 325 trials, and only 4% of the time did it dispense change incorrectly. So you're telling me that it happens all the time, which means it's certain to happen. But I'm telling you it's what? Unlikely to happen, because it only happens 4% of the time. In fact, if you go to that machine and make 25 purchases, so let's say you work somewhere that has this in their break room, and that would be 5 weeks of working Monday through Friday. Every day you go and take something out of that vending machine, 5 weeks. How many times in that 5-week period would that machine make the wrong change, according to this experiment? 1 time. We should have gotten 1. 1 time. Not always, right? Does that mean it still should be fixed? No, but it's not really likely or certain that you're doing the wrong change. Okay, anybody unclear about how to work with this stuff and the vocabulary that goes with it? Isaac?
How would you label it?
How would you what?
How would you label
How would we label this one? 1 time. Because it said how many, predict the number of times. So we would give this one a label of time, I guess. Right.
Alright, so if, per se, if I'm flipping a coin and I only flip the coin 3 times and then all 3 land on 10, would it be written as a 0% chance of getting the tails, or would it still be 50%?
It would be a 0%
So,
experimental probability.
so then it would be experimentally, it would say that it's impossible to get
Right.
tails.
as according to your experiment. So there's something to learn from that. If you're going to, when do you think the experimental probability is closest to the theoretical probability? The more trials you run, or the less trials you run? The more, because 3. I mean, is it possible you could flip 3 heads? Yeah. But if you did it 300 times, what do you think really would happen if you looked at 300 times? Would you get heads 300 times ever in an experiment? Chances are not. Chances are not. So the more trials you run, the closer it gets to the theoretical probability. But when you run an experiment, the probability of your experiment getting heads was 100%, not getting heads, getting tails was 0%, according to your experiment. So then you would predict, you know what, so let's say the next time you're gonna call heads or tails to pass this class. And you just did that experiment, and you say, well, according to my experiment, I have a 100% chance of, if I call heads, all is well. So I say, make the call. If you want to pass this class, you gotta make the right call. I'm gonna flip a coin. So Brighton says, well, according to my experiment, it seems like heads is a good call. So he calls heads. Does it have to happen that way? No. Because the sample space still has a heads in it and a tails in it, doesn't it? Yeah. So good question.